In the last video, we read the story about the moose population and what was happening to them because of the ticks. This next multiple choice question is about that story. So it says, increased average yearly temperatures in regions presently inhabited by the moose could result in a disruption in homeostasis in these animals because... Now, the first answer is definitely wrong because the question says increase and this says decrease. So that's not what we're looking for. Then we're looking, number 4 says the moose will sweat more. But if you remember back in the reading passage, they actually specifically say moose cannot sweat. So that can't be the right answer either. So I'm going to cross out number 4. So now we're between an increase in average temperature will decrease the amount of blood ticks can consume, or moose will not be able to maintain an appropriate body temperature since they do not sweat. Out of those two choices, only one of them is talking about the moose's homeostasis, and that would be number 3. The other one you have to make an inference about ticks and how much blood they're able to suck, but the moose not being able to regulate its temperature is where it's at. Next question's on the next page. Okay, so here we've got base your answer to questions 48 and 49 on the information and diagram below and on your knowledge of biology. The diagram represents the evolutionary relationships among many organisms. Now, when I graded this, I noticed that people didn't read this little spot right here. So this is evolutionary relationships. It's not a food web and it's not a food chain. It's talking about how these species are related to one another. So in question 48, it says, an environmental change severely affected the organism represented by species K. So let's highlight species K here. What was the result? Support your answer. So if you notice, here's present day, here's species K. Species K no longer exists in the present day time. When something no longer exists in present day, we call that extinction. So we could say species K was not able to adjust to the changes and it did not survive, which caused it to go extinct. So that is basically what the answers here say. So species K did not survive, they were not able to adapt. Species K became extinct because they could not survive in the changed environment. They became extinct. The diagram shows that they did not survive to the present. So any of those, as long as you're telling me extinction happened or not surviving happened, that's what we're looking for in that answer. The next question is about the relationships between 3 species, and I want to know which have the most similar traits. So what we're looking for here is which 3 are the most closely related, which ones have branches that touch each other the most. So we really would expect to see it's in one of these triangles here. So it's either this guy, this triangle here, this triangle here. The closer they are located together on the branching diagram, the more closely related they are. So for this question, we've got D, H, and J. D, H, and J form this little triangle here, which means they're more closely related than everybody else is. So it's going to be choice 2. Next up, it says base your answers to questions 50 and 51 on the diagram below and your knowledge of biology. The diagram represents trophic levels in an ocean environment. Notice that I'm reading the instructions out loud to myself, or to you. You should be reading them to yourself when you're attempting these questions. Don't gloss over the instructions. They have little clues in them, like trophic levels. So we're looking at this food pyramid, number 50. The organisms found at the second trophic level of this pyramid would be, so here's the second trophic level. These little guys are eating what's below them. So if you look below, you'll notice all of these are plants. All of these are autotrophs. And what eats plants primarily is an herbivore. So those guys are all herbivores. Choice 4 is the right answer. 51, state one reason why there's less energy available at each trophic level going from the first to the third trophic level. Now, we talked about this in class the other day. I said that what's happening to this energy here? Where is that going? So originally, we had all this energy here. It should be up here, but it's disappeared. Where did it go? And where it went was the plants used it to do their metabolism. And then these little guys are using the energy in their metabolism before they get eaten by that fish. So this missing chunk of energy here is used by the organism in order to live. So the way that they phrased it on the answer key is that some of the energy is used by the organism in each level and is not available to organisms at the next. You could simply say energy is lost, or if you want to get really complicated or technical about it, you could say that the energy is lost as heat, because remember, heat is a waste product of metabolism. So those are some possible answers to that question. And I'm going to cut this off and start a new video.